Hello everyone. So welcome to the live session again. In this session, we are going to talk about the five timer IC, and we have the expert here, Mr. Suresh Dwivedi. So let's welcome him, and let's begin with the first question on the five timer IC. So what is five timer IC, and what does it do? I think your audio is mute. Yeah.
Actually, triple five IC, which is also known as any triple five or LM triple five IC, is a very versatile integrated IC, which is a timer IC and very useful for the electronics student and electronics industry. Actually, it is a timer which can be used as a oscillator capable of generating different frequencies, delays or oscillations. At its core, triple five IC consists of comparator inside. This is actually hardware of the IC is this like this. It comes in a different package. It is a deep package, which is 8-pin IC, and it also comes SMD ICs package. So it's internally it has a comparator, voltage divider, flip flop, discharge transistors, etc. and a register network inside the internal. Its functionality relies on the external components like resistor, capacitors, and the power supply to tailor the operation of the specific application. Its working voltage is, I think, 5 volt to 18 volt maximum it works. It is a very small IC, but its working voltage range is from 5 volt to 18 volt. The triple five IC can operate in three main modes: stable, monostable, and bistable. We will discuss later. In the stable mode, it generates a continuous square wave output with the different frequency duty cycle, which is determined by the external capacitors, resistors, capacitors, etc. etc. It in stable it triggers when it output goes high for a particular RC networks. So this is the in the mode of the monostable. In bistable, it functions as a flip-flop, maintaining one of the two stable states until triggered or changed. Overall, you can say triple five finds extensive use in various electronics circuits such as timer, pulse generator, voltage controlled oscillator, LED flashes, and tone generator due to its simplicity, reliability, and the versatility. That's all.
Okay. So as you say, so about the timer IC uses. So where the how triple five IC commonly used in electronic circuit?
Triple five IC is commonly used in electronics industries for the various applications. Due to, due to its versatility and ease of use, some common use includes timer circuit, means it is used as a timer. In the triple five timer can be configured as a timer in either monostable or stable. As explained earlier, in the monostable, it generates a single pulse, means when its input is triggered by a pulse or a by switch in the monostable, its output depend on a particular RC network. So in that time, it will be
Sir, I am sorry to interrupt. Your voice is not coming. Yeah, yeah. Now it's
Right,
clear.
I see. The 555 can be configured in a timer in either monostable or stable multivibrator. In monostable, when its out input is triggered by switch or by a microcontroller or by any other sources, then its output remains high based on the RC network, right? And it is also useful on applications such as time delay circuits, pulse width modulation, and debound circuits. But in the stable mode generates a continuous square wave output with the frequency and the duty cycle determined by the external component which is used during designing. This is used application as such. A stable multivibrator is used as a clock generator, tone generator, and the LED fan flashers. When you want to flash LED, then you have to design in a stable multivibrator. When you want to design for a particular time period to on any flasher or any other thing, then you need to design as a monostable. Similarly, oscillator circuits. Oscillator circuit functions as an oscillation, generating a periodic oscillation. For example, in the stable multivibrator, it produces a continuous square wave, making it suitable for applications such as generating clock signals. Suppose you want to generate a clock and use it producing audio tone. Suppose you want to generate 1 kilohertz audio tone, then you can design in a oscillator mode, that is a stable multivibrator mode, and driving the LED displays, etc. Similarly, pulse generator. 555 IC can generate precise pulse of the varying width and frequency, making it useful in application such as pulse width modulation. You know, the pulse width modulation is also very important, which controls the servo motor and frequency synthesis. And the next is voltage controlled oscillator. Using this application, you can modulating the control voltage input. Frequency of the oscillation is a stable mode. Can be controlled, making the 555 suitable for voltage controlled oscillation application. And next one is a switching circuit. 555 can be used as a simple switching controller, turning on or off external components such as LEDs, relay, transistors, based on the timing configuration. Overall, 555 IC is widely used in hobbyist projects, educational experiments, and professional application due to its simplicity, reliability, and wide range of the functionalities. That's all.
Okay. So, my next question is, can you explain the internal architecture of the 55 IC?
Sure. The internal architecture of the 555 IC consists of several key components that works together to provide its functionality. Here are brief overview. You can understand what are the steps. First is voltage divider. Internal circuit, when you go its internal architecture of the 555, then you see first function, main internal architecture is the voltage divider. 555 IC contain three voltage divider resistance labeled R1, R2 and R3. These resistors set trigger, threshold and discharge voltage levels respectively. Internally, it uses three resistors, right? Another is comparator. Internally, 555 IC has two voltage comparator labeled comparator 1 and comparator. These comparators compare the voltage at the trigger and the threshold input with reference to the voltage and produce output signal accordingly. Comparator 1 and comparator 2, accordingly they change their output. And third one is a flip-flop. It contains SR, it means set and reset flip-flop. In this mode, it is used as a bistable mode, means when set and reset. So its main is flip-flop SR, flip-flop that controls output state based on the input forms of the component. The flip-flop determines whether the output is high or low. Suppose if you have a high output, then again trigger, output will be low and remains low until you are not triggering the again. Right? And fourth one is the discharge transistor. Triple five include a discharge transistor that is used to discharge and the external timing capacitor when necessary. This transistor is controlled by the flip-flop. And fifth is output driver. The output driver amplifies the signal from the flip-flop and drives the external load connected to the output pin of the triple five. And six is voltage control, CB, which is normally known as pin 5. CB. The output driver amplifies the signal from the flip-flop and drives the external load connected to the output pin of the triple five. Next is a reset pin, which is normally known as, I think, 5 pin. This pin allows the immediate resetting of the internal flip-flop, overriding the current state, whatever it is. Suppose high, when you reset it, it becomes low. When already low, then it becomes high. Setting the output to no state. In brief, you may say that the internal architecture of the triple five is designed in such a way so it provides timing and oscillation functionalities and flexibility and reliability. By configuring the external components connected to the IC, user can use its operation according to their application. That's all.
Okay. So, what are the some special typical application of the triple five IC?
Yeah. The typical application of the triple five is very versatile. Some typical application include such as the timer circuit, oscillator circuit, pulse generator circuit, voltage controlled oscillator circuit, switching circuit, LED flasher. There are various typical applications. In the timer circuit, which is the very most and common use of the triple five timer, it configure either mode. Either you can use it monostable or it stable based on your application. It has a precise timing oscillator based on the R resistor capacitor. Its main control the external components are resistors and capacitors. Timer circuits are widely used in the applications such as time delay circuit, pulse width modulation, and the bound circuit. And in the oscillator circuit, triple five functions as oscillator, generating periodic oscillators, and similarly, a stable mode, it produces a square wave suitable for the clock, etc. etc. I have explained earlier. Similarly, pulse width modulation. In the pulse width modulation, it is also a stable multivibrator. The main function in this pulse width modulator, you can change the duty cycle. Duty cycle means either its on time is high or on time is low based on the duty cycle. So, this is the reason why it is known as pulse width modulation. This capability is very useful for such pulse width modulation, servo control, frequency synthesis, and generating signals, etc. Right? And the next one is the voltage control oscillator. By modulating the control voltage input, You can use it as a frequency oscillator in a stable mode control. This makes 555 suitable for voltage controlled oscillator application where the oscillation frequency need to be varied based on the external component. That external component is what? R and C. Right? And switching circuit. Switching circuit, the 555 IC can use as a simple switching controller, turning on or off external components such as LED, relays, or transistor. LED flasher, you can use as a LED flasher, normally generating blinking pattern of the turning LED on and off accordingly. Right? And the tone generator. Suppose you want to test an audio signal, then you need a particular frequency. Suppose you want 1 hertz, the audio range, then you can design a stable multivibrator in audio range. So that is normally known as tone generator. So these are the few examples which I have explained is the main application of the triple. That's all.
Okay, so we have one more question from our viewers. One of the viewers have asked that I need a FM booster circuit. So, is it possible to make such circuit from the 555, or you have any reference circuit for that?
I don't think it is a very booster circuit. I
No,
not
no,
very
FM, he is asking, I need FM booster circuit diagram. So, is there any circuit can be made using that IC, or it can't be used for those things?
I don't think we are using this IC as a booster circuit.
Okay, 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 okay. So, you can check on the circuit diagram using different IC. This IC can't be used as the FM booster circuit. So, let's go on the next question. How does 55 IC function as a timer?
Suppose for the timer, primarily it has two functions. One is a monostable, another is a stable multiplier. In the monostable, it produces a particular time. Suppose you want to activate some relay or some appliance for a particular time. Say, if you want to uh, activate the output for 5 minutes, okay, then monostable you have to design in the monostable mode. In monostable mode, R and C will be designed, and when you want stagger, then output will be high. And in both cases, R and C is very important, which you have to maintain. So you have to select accordingly. There are various component select timer. Calculator are available. Then various calculators are available by which you can select the R1, how much it should be, RC, how much it should be for a particular output. Suppose you want to 2 minutes, then what the value R1 and C1 should be. Suppose you want to 5 minutes, the what value should be. You have to calculate it. Say it has a particular formula, right? And similarly, for the stable multivibration mode, frequency and duty cycle is very important. As I have explained it internally, you have to select two resistors in the stable multivibrator, say R1 and R2, and capacitor C. When you are designing in a stable multivibrator, you have to use two resistor and one capacitor. In the monostable, you need one resistor and one capacitor. So accordingly, time can be decided. For example, in external multivibrator, when you are two resistors, say R1 and R2, then you can calculate the frequency. Then frequency can be calculated upon 1 F equal to 1.44 upon R1 plus R2 multiplied by capacitor. So this is the frequency. When you divide it, then you will get the time period. So with this simple calculation, you can calculate this and how much it's on time and how much that is depends on the duty cycle. So in brief, in both modes means a monostable as well as unstable multivibrator, it utilizes its internal components, flip-flops, and other components to generate the desired timing behavior. So you have to decide which is suitable for your output, and accordingly you select the resistors and capacitors accordingly. That's all.
Okay. So as you said regarding the circuits, so is there any variations or derivatives of 5 IC commonly used in the circuit?
Yeah, there are various variations and derivatives of the triple five that offers additional feature or improvements over the original circuits. Some are as one is a triple five, sorry 556 dual timer. This is the same timer in triple five. You have only one timer. When you have 556 IC, then it same IC you have a dual timer. So this is another alternative variation of this. So the 556 is essentially two timer. Means when you are you in your design you need two triple five, then instead of using this triple five, you have to use 556 IC in a single package, which allows more complex timing circuits or multiple independent timing functions within a single IC. Another is NE556, TLC556, LM556, and similarly LMC55. LMC triple five is a low power version of the triple five IC, which is designed to operate the lower power consumption compared to standard triple five IC. So it is suitable for the battery powered application or other low power circuits. So this is the very important IC. And next one is the LM triple five, NE triple five, which is the CMOS timer. This CMOS version of the triple five IC, CMOS technology offer advantages such as lower power consumption, wider operating range, and higher frequency capability compared to the original bipolar triple five IC. Next one is a triple five timer with digital output. Some variation of triple five IC include additional circuitry to provide the digital output signal, making them suitable for the interfacing with digital logic circuits or microcontroller. And triple five timer with adjustable duty cycle, certain variation of triple five incorporate feature to adjust the duty cycle of the output waveform without changing the timing component. This is the advanced version, offering more flexibility in the waveform. Normally, in the duty cycle, you have to change duty cycle based on the R1 and R2. But few advanced version of the IC comes without changing the components. You can change their duty cycles. And surface mount version, many IC comes with the surface mounted. For example, this is which I have seen. This is deep package, and few packages are available in the SMD. it uses less space itself, and it is very useful for designing use less space. That in these variations, the end weight derivatives of the triple five provide designers with the option to tailor timing function to specific application requirement such as power consumption, size constraint, or additional feature needed for the circuit. That's all.
Okay. So we have one question from the one of our viewer. Uh, can multiple IC be used in same component with different application?
Yes, you can use so many circuits in a same circuit. For example, suppose you are designing a clamp circuit, okay, and want to operate your uh, appliance or relay after three clamp, one, two, and three. Then use first IC for a particular time and its output connect to the another IC and another IC, second IC triple five use another IC. So naturally multiple ICV can be used in a same circuit.
Okay, that's the good. So can you also explain the different modes of operation on the IC?
Certainly. I have explained earlier in the stable multiplier, these are only their main modes which is designed using this IC is three modes: a stable multivibrator, monostable multivibrator, and bistable multivibrator. In the stable multivibrator mode, it generates a square wave and duty cycle can be controlled using different values of the R1, R2, and C. In this stable multivibrator, we need at least two resistor and one capacitor. So, and it produces a continuous square wave that can be also used as a sawtooth generator by connecting few resistor and capacitor at the output of the amp. But basically, it produces the stable multivibrator. So, the frequency of the output waveform determine the value of external resistance R1, R2, and C. This is the range. Duty cycle. What is duty cycle? The ratio of the pulse width to the total period can be adjusted by varying the value of the external component. So, in commonly, you can say it is used in the applications such as clock, generator, LEDs, and flasher. But in the monostable mode, as I have already explained to you, once you trigger for a particular time, its output be high. And third, which I have not explained earlier, I think. So third one is a bistable mode. Bistable means first when you trigger, output remains high unless until you will re-trigger again. So that is known as bistable means. When you trigger and output, say light is on, it remains on unless you again re-trigger the input. When once trigger, output will be high. Once you again trigger, output will be low. When again trigger, and output be high, like this. This is the bistable. That's all. Three modes are commonly used in this one. That's
Okay. So how do we calculate the timing intervals in the stable and monostable modes?
all. This is very important question and useful. Going to design, you have to select R1, R2, and C3. Suppose your output is 1 kilohertz, then you have to select accordingly. Suppose your output is 100 kilohertz, then you have to select the different one. Various calculators are available easily in the net. Otherwise, but main funda of generating the frequency or the time period is suppose R1, you have select three components R1, R2, and C1. Say R1 value is 1K, whatever it is value, R1, R2. Then you can frequency. Frequency can directly be calculated through the formula easily available in the net, and we are just telling you F equal to 1 upon F equal to 1.44 upon R1 plus R2 into C. That is the main formula. F equal to 1.4 upon bracket में R1 plus 2R2 into C. And when you calculate this, then you will get the frequency. When you reverse it, then it will be the time period. Means it the such time will be on, such time will be off, such time will be on. And for calculating the duty cycle, let's suppose duty cycle equal to R1 plus R2 upon में R1 plus 2R2. When you calculate using this formula, then you can easily calculate the duty cycle. So these are the two formulas which are useful for calculating the time interval of the stable multivibrator. For the monostable calculation, because it needs only one component, means only one resistor and one capacitor, so its calculation is simple. When R say first value is R, resistor and capacitor is C, then T equal to 1.1 into R into C. So you will get the time period. When you reverse it, then you can easily calculate the particular frequency. Means it is normally known as time output high or low. Suppose if you want to your appliance on for a particular period, then you have to calculate T equal to 1.1 into R into C. For this period, your output will be high. This is the simple formula for calculating the time period of the monostable voltage. That's all.
So, what are the consideration you take while using the 555 IC in practical circuits, such as power supply requirement and temperature sensitivity? So, what are the factors that you take consideration while using those?
This is good question. Suppose when you are using the 555 in a practical circuit, so there are you have to consider various factors in which first is the power supply requirement. When you are designing a circuit, then keep in your mind that how much voltage you are using to use this one. Suppose you are using a 5 volt circuit, then which IC is useful. Suppose when you are using 18 volt voltage, then this package is useful. So this is very important factor. The power supply requirement, you have to check it during designing. With triple five C, triple five I have explained. Triple five normally used at 4.5 volt to 15 volt. Sometimes it may use 18 volt too. But normally we have to abide to its maximum capability. Although you can use it up to 15 volt, but we recommend that you have to use it maximum 12 volt for better design. So this wide range of the circuit, it has a wide range of the voltage circuit to design, while 4.5 volt to 15 volt. So ensure that the positive power supply voltage meets the specific requirement of the 555, which remains within the recommended operating range to prevent the damage and ensure. So you have to consider the power supply range. You, you do not use more than this range when you are designing a circuit. Next one is a decoupling capacitor. Decoupling capacitor is used for fluctuation. Suppose in your power supply there is a various fluctuation, so To minimize the voltage fluctuation and noise in the power supply lines, it is very useful when you use a decoupling capacitor, which is a normally ceramic sizes ceramic capacitor. You have to use near the power supply where is power supply pins and you have their use. And this will prevent when externalize voltage fluctuation, then it will save your triple five IC. So these capacitors help stabilize the voltage supply and improve the IC's performance, especially when you are using your circuit in the noisy environment. So don't you avoid to use this decoupling capacitor. Means in general way, decoupling capacitors are the capacitor used near the power supply pins of the IC. So you have to use this one for better design. And temperature sensitivity. The performance of triple five can be sensitive to the temperature variations. So you have to use a temperature compensated components such as capacitor resistance in the timing circuit. Additionally, provide adequate ventilation and thermal management to prevent overheating, which can affect the accuracy of timing interval. Suppose you are using a monostable, when your temperature is too high and the resistance value or capacitor value may increase or decrease, so your output may vary. So we have to keep in mind that you are that component which is the temperature sensitivity and tolerance. So next one is tolerance. Tolerance is also very important. You, when you want accurate output of the stable as well as monostable, then you have to use that component which has very less tolerance. Suppose few resistors and capacitor having 20% tolerance. So your calculating that output will be this, but actually it will not be because of the you are using the tolerance, you are not keeping your right the tolerance of the resistor. Some resistors having 20% tolerance. So according will result will. So better tolerance component should be used. The accuracy of timing interval in the circuit uses triple five depends on the tolerance of the external components such as resistors and the capacitor. So we advise the high quality component with the tight tolerance to achieve the precise timing interval and minimize variation in the circuit's behavior. And next one is input signal conditioning. You have to consider the what is the input signal. Debouncing may take place. So ensure the input signal to trigger and control pins of the triple five meet the specific voltage level and the signal characteristic. For example, suppose your whole design is for 12 volt and your signal the input signal is a 5 volt. So it will not be met. So input signal as well as the total circuit design should coincide. So that is the reason. So proper signal conditioning such as filtering, voltage level, shifting may be necessary to prevent the false triggering and ensure reliable operation. So when you are using a switch to trigger it, then you have to use a debounce capacitor. So next one is the output loading. Suppose consider the loading effect of the external component connected to the output of the pin of the suppose pin 3 is its output and its maximum capacity say 100 milliampere. Then output should be used in such a way that load should not be more accordingly. So excessive loading can affect the output waveform characteristics and may require buffering or additional driver circuit to maintain it. Otherwise, your IC will be heated and will damage too. And seventh one is electromagnetic interference (EMI). In high frequency, in the normally it is not useful in fire testing, etc., and breadboard, etc. But in high frequency or sensitive application, electromagnetic interference and EMI can be affect the performance of the triple five. So proper grounding, shielding, and layout techniques help minimize EMI and ensure stable operation of the circuit. So normally when you are a precise means high sensitive frequency output is using, then it is essential. For the low output frequency, you can avoid for that. So these are the main parameters. That's all.
Okay. So how does this RC function as a oscillator and the pulse generator? I think your audio is mute.
Sorry. I have already explained versatile integrated circuit is various electronic circuit related to oscillators. How functions as a oscillator? First, internal structure, external components, internal flip-flop, charge discharge, threshold and trigger, output signal. These six parameters functions as a oscillator. And you have use this one. So by adjusting these six means internal structure, external component, internal flip-flop, charge discharge, threshold trigger, these are the only parameters which functions it as a oscillator. By adjusting the value of these external components, you can control the frequency and duty cycle of the output waveform which is generated at its pin 3. Okay, making it suitable for various timing and oscillation application in electronics circuits. I have already explained such questions. That's all.
Okay. Okay, thank you. I request the viewers to, if you have any more questions, then you can ask us, and you can also leave the question in the comment. We will take it. So if you have any question, you can ask it right now. Otherwise, you can post the question as a comment later if you see it later. So we have no more question. So thank you everyone. Thanks uh, for spending your time here, and I hope you have a lots of takeaways from here. So thank you, and thank you, Suresh, Mr. Suresh Dwivedi, for giving your valuable knowledge and sharing your expertise with us. Thank you.
Thank you, Ashwini. Thank you.